All right. So you sent over some really interesting stuff about pricing
Yeah.
and we talk about marketing a lot on the show, and
Mhm.
I think pricing is one of those things that people maybe don't think about as strategically as they could.
Oh, for sure.
You
It's
know,
so fundamental,
it is.
and it really can make or break your business.
Yeah. So we're gonna kind of do a deep dive into pricing today,
Yeah,
based on what you sent over,
sounds good.
and I guess maybe uh, the starting point for all this is the demand curve.
Yeah, the demand curve.
Like what is that?
Well, so at its most basic, right, it's the relationship between the price of a product and the quantity of that product that people are willing to buy.
All right. Okay. So like common sense, if something's more expensive,
Hmm.
people are gonna buy less of it.
Exactly. And the interesting things, you can actually represent this visually
Okay.
and mathematically.
Yeah.
And the materials you shared actually focus on what's called a linear demand curve, which is a really nice way to start thinking about this.
Okay.
So it's basically a straight line.
Mm-hmm.
And the equation they give is demand equals 390 minus zero point 0.1 times price.
Okay. So you can just like plug in a price into that,
Exactly. And it'll spit out a number for demand.
and they give some examples in here.
Yeah,
Yep.
like if you were to price the product at $0,
Right. Free.
which is free, yeah, then the model predicts that demand would be 390 units.
So that's kind of like the theoretical maximum size of your market. If
Yeah, absolutely.
everyone
Exactly.
who could possibly want it got it for free.
Everyone gets it, yeah.
Okay.
And on the flip side, they also give the example of if demand drops to 0,
Right.
that would happen at a price of $3,900.
Okay. So basically nobody's buying it.
Nobody's buying it at that price.
Yeah.
And then they give an example in between those two extremes,
Mm.
which is if you set a price of $100, then the demand would be 380 units.
Okay. So that's interesting. So for every $100 increase in price,
Mm-hmm.
demand drops by 10 units. Yeah.
Exactly. Yeah, that's the relationship captured in that point 0.1
Yeah.
in the equation.
Okay, cool. So,
Yeah.
but how do you actually like figure out what your demand curve is?
Yeah, so that's a great question. And the source actually touches on that. They have this scatter plot example.
Okay.
And the idea is you can plot your historical sales data.
So like over the last year or something.
Yeah, exactly.
Yeah.
So each dot on that scatter plot represents a price that you've charged in the past and the quantity that you sold at that price.
Oh, okay. So you just put a bunch of dots on a graph. Yeah.
Exactly. And then what you can do is you can draw a line that kind of best fits those points.
Oh, so like a trend line through the data.
Exactly.
Yeah.
Yeah, a trend line. And the source even points out that, if that trend line happens to be a straight line, then the equation of that line is your demand curve.
Oh, wow.
And in their example, the equation of that trend line is y equals negative 0.1x plus 390,
Which is the same.
which is the same demand curve that we've been talking about.
That's really interesting. Okay, so we've got like a pretty good grasp, I think, on this idea of a demand curve.
Mm-hmm.
But like the thing that businesses really care about is profit.
Right, exactly. How do we actually make money from this?
Yeah. So how does all this tie into profit?
Yeah, so that's where the profit formula comes in,
Okay.
which the material presents as profit equals price minus variable cost times demand minus fixed cost.
Okay, so that's a mouthful, but
But it's actually not too bad when you break it down.
yeah.
They use this example of a vacation package
Right.
to illustrate this.
Okay, I like vacations.
Yeah. So let's say the variable cost for this vacation package is $100.
Okay, so that's like the cost of the hotel room and
Exactly. Yeah.
Yeah.
The things that change directly with each package you sell.
got it.
And the material suggests an optimal price of $2,000
Okay.
for this package.
All right, so if we plug that price into our demand curve equation, the one we talked about earlier,
Yeah.
we get a demand of 190 units.
Exactly. So then to calculate the profit, we just take that price of $2,000, subtract the variable cost of $100, and then multiply that by the demand of 190 units.
Okay, so that's $1,900 per vacation package
Mm-hmm.
times 190 vacation packages.
Exactly. And that gives you a profit of $361,000.
Wow. Okay.
Yeah, and the source even gives this really helpful visual for this. They talk about how you can represent that profit as a rectangle on the demand curve graph.
Okay.
So the length of that rectangle is your profit per unit, which is that $1,900.
Price minus variable cost.
Yeah, and the height of the rectangle is the demand, which is 190.
So the area of the rectangle is your total profit.
Exactly.
That's pretty cool.
Yeah, and here's a really important point that they bring up.
Okay.
They say that the optimal price the price that will get you the absolute most profit actually doesn't depend on your fixed costs.
Okay, wait a second. Explain that a little bit more because I
Sure.
thought fixed costs were part of the profit calculation.
They are. But think about it this way. Fixed costs are things like rent or salaries,
Mhm.
stuff that stays the same no matter how many units you sell.
Got it.
So they're basically a constant deduction from your total revenue.
Okay.
They're going to reduce your overall profit for sure, but they won't actually change the specific price point
No.
where your revenue minus your variable costs reaches its maximum.
Okay, so if your fixed costs are like $50,000 versus $100,000, it's
Yeah.
not going to change the price that you should charge to
Exactly.
maximize your profit.
Yeah, it's a really key insight because it lets you really focus on that price minus variable cost part of the equation
Yeah.
when you're trying to find that optimal price.
Gotcha. Okay, that makes sense.
Yeah.
So the source also has this graph showing how profit changes as price changes,
Mhm.
and it's not just a straight line upwards, is it?
No, it's definitely not. It's what we call nonlinear.
Okay.
So the graph shows that as you increase the price from a low starting point, your profit does tend to increase.
Right.
But that doesn't go on forever.
Okay.
Eventually you reach a peak, and that's your optimal price.
So if you go higher than that,
Yeah, if you keep increasing the price past that point, your profit actually starts to go down.
and that's because you're selling less and less.
Exactly.
Yeah.
Yeah, you're making more profit per unit, but you're selling way fewer units.
So it's all about finding that balance, right?
Yeah, that's the sweet spot.
Okay, so instead of just like guessing at the price,
Mm-hmm.
um, how can we actually like figure out what that optimal price is?
Well, that's where Excel Solver comes in.
Okay. I've heard of that. Is that like
Yeah, it's a really powerful add-in for Excel
Okay.
that can help you find that optimal price automatically.
Okay, cool. So it does the math for you.
It does. Yeah, so you don't have to do all the trial and error yourself.
Got it.
The source uses this fun analogy. They talk about a little guy trying to climb a profit hill.
Huh.
And Solver is kind of like that little guy. It's trying out different prices, calculating the profit for each one, and then it keeps moving in the direction that increases the profit.
So it's like climbing up the hill until it gets to the top.
Exactly. Yeah, it's searching for that peak profit.
I like that.
Yeah. And the source also compares Solver to another tool in Excel called GoalSeek.
Mm-hmm.
Have you ever used that one?
I think I've seen it before, but I don't really know what it does.
Yeah, so GoalSeek is more about working backwards.
Okay.
You're trying to figure out what input you need to achieve a specific target output.
So like if you want to make a profit of $1 million.
Exactly. Yeah, what price do I need to charge to make $1 million in profit?
Okay.
Solver is a bit more powerful than that. It lets you maximize or minimize a value like profit
Mm-hmm.
by changing multiple input variables at the same time.
Gotcha.
And they also mention these different solving methods within Solver.
Yeah, they had a whole list.
Yeah, there were 3 of them.
Yeah, I got a little lost in the weeds there.
Yeah, it can get a bit technical. But the first one they mentioned, GRG nonlinear, is a good starting point for most pricing problems.
Okay, what does that even stand for?
It stands for generalized reduced gradient.
Mm-hmm.
But the main thing to know is that it works really well for situations where the relationship between your variables is smooth and curvy.
So like our profit versus price curve.
Exactly. Yeah, it's not a straight line. It's got that curve to it. And GRG nonlinear is designed to handle those kinds of curve.
Oh, okay.
And the reason our profit curve has that shape is because the price appears in the profit calculation in a way that creates that curve.
Okay.
You know, it's in the price minus variable cost part and also in the demand part, which is also function price.
Yeah.
So it's like the effect of the price gets kind of squared.
Okay.
And the source even says that calculations involving things like squares, exponentials, logarithms, and powers are all good candidates for GRG nonlinear.
Okay, cool.
Oh, and they also mentioned something called multi-start within GRG nonlinear.
Okay.
Do you remember that profit hill analogy?
Yeah, the little guy.
Yeah. So imagine that hill has a few smaller peaks before you get to the highest one.
Okay.
Solver might start off on one of those smaller peaks and think it's found the best solution.
Oh, so it might stop too early.
Exactly. Yeah, and multi-start basically tells Solver to try starting from multiple different points on that hill.
So it doesn't get stuck on a little bump.
Yeah, exactly.
Right.
So it's more likely to find the absolute highest peak, the true optimal price.
Okay, that makes sense.
Yeah. And even though our example is pretty simple, it's generally a good habit to use multi-start just in case.
Okay, good tip.
Yeah, the other 2 solving methods they mentioned, Simplex LP and Evolutionary, are for more specific situations.
Yeah.
So Simplex LP is for linear programming problems, where the relationship between your variables is a straight line.
Okay.
And they use this analogy of butter and guns.
I remember that.
If your goal is like a simple combination of those resources
Right.
without them being multiplied by each other or anything, then Simplex LP is the way to go.
Okay.
But our profit calculation involves that price squared thing. So GRG nonlinear is a better fit for us.
Gotcha. And what about that evolutionary one?
Yeah, so evolutionary solver is good for problems where you have sharp turns or jumps in your data.
Okay.
Like if you have different pricing tiers or discounts that kick in at certain sales volumes.
Oh, that makes sense.
Yeah, those kinds of things can create sudden changes in your profit curve.
Mm-hmm.
And evolutionary solver is good at handling those.
Okay.
But for our basic linear demand curve example, GRG nonlinear is a good place to start.
Awesome. All right. So we've talked about demand curves and profit and Excel solver,
Mm-hmm.
but there was one more thing in the materials that I thought was really interesting.
Yeah, what was that?
This idea of product tie-in pricing.
Oh, yeah, the classic razors and blades.
Yeah, exactly. So
Yeah.
can you explain that a little bit more?
Yeah, so it's also sometimes called loss leader pricing. And the basic idea is that you sell one product at a low price.
Right, like the razor.
Yeah, maybe even at a loss to get people to buy it. But then you make your real profit on the complementary product that they have to keep buying.
The blades.
Yeah, the blades, exactly.
Okay, so how does that work? Like, why would you sell something at a loss?
Well, because once someone buys your razor, they're kind of locked into buying your blades.
Oh, because they're designed to work together.
Exactly. Yeah, there's that compatibility issue.
Okay.
So you can charge a higher price for the blades, and people will keep buying them because they need them for the razor.
So you're making your money on the blades, not the razor.
Exactly.
Yeah.
It's about the long-term profit, not just the short-term profit.
So how do you actually figure out what the best price is for the razor in this kind of situation?
Yeah, so the source actually outlines a two-step process for this.
Okay.
The first step is to calculate the profit you would make from selling only the razors.
Okay.
And you can use your demand curve for razors to do this.
Right.
And you find the price that maximizes that profit.
Okay, but that's not the whole story, right?
No, the second step is where it gets really interesting. You have to calculate the total profit, which includes the profit from the razors and the profit from the blades.
Right. Okay, so you have to take into account how many blades people are going to buy.
Exactly. Yeah.
Yeah.
And how much profit you make on each blade.
Got it.
And when you do that, the optimal price for the razor might actually be lower than what you found in that first step.
So you might actually want to sell the razor for even less.
Yeah, because by making the razor cheaper, you're getting more people to buy it,
Right.
which means you're selling more blades in the long run.
Yeah. Okay, so it's all about maximizing that total profit,
Exactly.
not just the profit on one product.
Yeah, and this isn't just limited to razors and blades.
Right. I was thinking about that.
It's everywhere.
Like game consoles and games
Exactly, yeah.
and printers and ink.
Mm-hmm. And coffee makers and coffee pods.
Wow. So this is like a whole new way of thinking about pricing.
It is, yeah. It can be really powerful.
Cool. Okay, so to recap, we've covered a lot of ground today.
We have.
We started with the demand curve.
Yeah, that fundamental relationship.
Right. And then we talked about how price and profit are connected.
Mm-hmm. And how that relationship is not always a straight line.
Right. And then we got into the nitty-gritty of using Excel solver to actually find that optimal price.
With GRG nonlinear.
Yeah. And finally, we explored this fascinating world of product tie-in pricing.
Razors and blades and beyond.
Exactly. So
Fascinating.
hopefully you're walking away from this with a much better understanding of how to think about pricing
I hope so.
and how to use data to make more informed decisions.
Yeah, move beyond just gut feeling.
Exactly.
This actually reminds me of a question for you to ponder.
Okay.
Think about all the products out there that have some kind of consumable or part of a larger system.
Right.
How could you apply these principles of tie-in pricing to those products?
Oh, that's a good one.
Yeah, could you unlock some hidden profit potential?
I'll have to think about that.
Yeah, it's worth exploring.
And you know, this whole discussion about price has really just scratched the surface of marketing.
It has, yeah.
You know, the source material mentioned the 4 Ps of marketing.
Right. Price, place, promotion, and product.
Exactly. So we still have a lot to explore.
We do stay tuned for more deep dives into the world of marketing.
All right. Well, thanks for joining us today.
My pleasure.
And we'll see you next time on The Deep Dive.